The slide shows the architecture of eXplain. On the left, we see the mainframe, which contains, so to speak the truth, the input data to be analyzed. In the middle is the so-called eXplain server, which in most customer environments is a Linux-based virtual machine. Important to note, nothing is installed on the mainframe. Everything is performed off-host. The source code is either automatically synchronized with the mainframe via FTPS or transferred to the eXplain server via Git mechanisms. It's also important to note that we truly work with source code, not compiler listings. We have our own preprocessor mechanism capable of resolving not only copies but also complex macro structures. The image above shows an open and documented API for importing additional data, such as execution statistics and information on transactions that are not available as source code. Our goal is a complete mapping of the mainframe landscape, which is why it is important to collect all available information. Everything that has been successfully processed is stored in a database repository, typically a license-free PostgreSQL database. Here, experienced eXplain users could already query the well-documented eXplain repository using SQL. Typically, users take advantage of eXplain's visualization capabilities. The Eclipse plugin is listed in the lower right corner. It can be integrated into existing Eclipse installations from other vendors, such as RD, IDZ, or others. Communication with the repository takes place via a secure JDBC connection. To provide additional user groups, such as business analysts, with an easy entry point, the latest releases also offer visualization directly in the browser or in Visual Studio Code via an extension. A Spring Boot server acts as the middleware here, which also communicates with the repository via secure connections, in this case, HTTPS and SSL. eXplain provides a deterministic data foundation for AI as well. Here, eXplain offers various export options to provide data for AI models.